in the previous lecture, I have taught you about the steps to make the geometrical construction. So in this lecture, I'll be teaching you about the geometrical construction of the molecule that is NH3, ammonia. So the steps to make that construction is these. So let's start making according to these steps. First step is central atom. As I told you in the previous lecture, central atom of the atom, or we can say that molecule, is that atom which has less contribution. So here in the ammonia, the less contribution is of N. So we will place N at the center, and we have 3 hydrogen atoms. So we will place 3 hydrogen atom at the degree of 90. After that, let's move to the second step. Second step is that we will make the valency filling, or we will make the bonds. Now here we know that the nitrogen have 4 electrons in the valence orbit, and we have to place these electrons with the 90-degree angle. So after placing 4 electrons in the 90-degree angle, there is 1 electron that is excess. Now we will place that 1 electron with another electron of the 4. So after that, we will be having a lone pair. That lone pair does not act in the geometrical representation, but still it has some we can say that role in making the degrees. So here we know that there would be bond in the valency with the valency of the nitrogen. After that, we will be deciding that on which axis which hydrogen will be. Now we know that at the first we have the axis of the S. After S, there would be all the P. This will be Px, this would be Py, and this will be Pz. So after these axes, we will move on to the next step, and that step is hybridization. Hybridization of the orbitals means mixing those orbitals. When we will mix these orbitals, we know that there is one S and 3 P's. So it will become sp3. So it is identified that all these electrons are present at the sp3. It's an irregular tetrahedron, because we know that if there is a form of the sp3, it will be something like this: S, then P, then P, and then P. As in the previous lecture, I have shown you the structure of the kite. So it will be sp3, but this structure would be tetrahedron and irregular. Now the word here irregular means it has a lone pair. As it is shown in this figure, it's a one lone pair here. So the degree here would be 107. If there is no lone pair, its degree would be 109. But still it has one lone pair, so its degree is 107. And the remaining hydrogen are shown as this, but if we draw it on the paper, its form would be dumbbell shape. So that's all about today's lecture, and for more molecules, watch my remaining videos.